SwayamPrabha. Digital India. Educated India.
Well, we are at the lecture 4 of module 7, and this module was mostly dedicated for damp proofing and insulation. So, damp proofing was taking care of building against water. Insulation, mostly we were discussing of taking care of the thermal gain, how to protect the building from thermal gain or from thermal loss, and also we had given some highlights on sound insulation. Yes, sound insulation is dealt further in details in architectural acoustics maybe, but today we are going to discuss on the materials which were essential for damp proofing and also for insulation, and we will also learn that how traditionally in our country or in similar climatic contexts some methods are adopted for insulation which are very low cost, and already we have discussed them in our previous lectures. So, some practices we will see and gradually we will move to bitumen, as we had seen application of bitumen widely in damp proofing. So, we need to know what that material is actually and how it is available in its different forms, and obviously that opens up the application of it, and we had also seen the application of it in damp proofing. Gypsum is the other insulator which was used to cover up the fiberglass or the mineral wool or the rock wool and give a neat finish. Gypsum perforated boards were used for sound insulation. Yes, that was on top of a inside hidden material of a sound insulator of maybe fiberglass or glass wool or rock wool. So, we will try to see the application of other applications of gypsum also, and let us now begin. So, maybe this picture you can see, this is made of terracotta. What you see is holes. We had discussed that yes, air is a bad conductor of heat and sound. So, you can see this kind of inverted pots, earthen pots, they are still in practice in our country, particularly when it is a roof, a large expanse. You can put in pots, earthen pots, inverted on the entire roof surface. Actually, you can place earthen pots on rooftop and then cover it with a screed concrete, that is mortar. So, this is the main roof. You have to have the waterproofing, and then you need to place these earthen pots and then cover it with concrete, light concrete mix. So, these trapped in air inside these pots act as insulator. This is practiced since many years. This kind of pots act as sound resonators. These can trap in particular frequency of sound when the case is the pot holes or the open sides are there to trap in the sound. That is seen in Suleiman Mosque, Hagia Sophia Mosque. There the entire dome, you can see holes all along. Those are nothing but pots or pitchers placed to trap a particular frequency of sound generated in that space. So, you can understand that we can use earthen pots inverted with air inside to trap in heat or sound, to trap in sound and to not allow heat. So, it can be used in both the ways. Again we come to cool roofing. What is that? It is very simple. Lime wash. Lime wash is a very low cost paint put on top of the roof surface. This is practiced in Ahmedabad, Bhopal. Around 3000 houses were done so, and there was a very good response. The inside got insulated, the solar radiation got reflected. So, we had learned reflective insulation. So, we are applying the same principle here at a very cost effective way to prevent the solar radiation to get entrapped into the inside of the building from the roof. It can help in taking away 80% of the radiation, and it is a very cheap method, but yes, there are problems. One may use the roof for some social purpose, for gathering, for keeping some item, maybe kind of storage. So, then this may not be that effective, but yes, it is an answer for insulation at a very different way. White ceramic tiles can be put on the rooftop. So, you remember the term white. White is reflector. Here we are not using metallic reflector. Metal is also a reflector. We discussed that. Glass as a reflector, we had discussed that. But here we are using the color white as a reflector with lime, with ceramic tiles. So, that can also help in achieving thermal comfort inside the building. Coming to wood, as I have told, trapped in moisture, trapped in air within glass fiber, steel, glass fiber, rock fiber, mineral wool, glass wool is the crux for thermal insulation. Wood is also a natural fiber, where within the wood, due to the removal of the moisture, there are air pockets formed, very small cellular structure, cellular level. So, this wood can act as a very good insulator. So, this wood lining on walls, inside walls, on ceiling, particularly in hilly region where it is abundant, you can get a thermal comfort inside. So, whatever be your building material, it may be concrete, it may be stone even, because stone is also abundantly available in hilly areas. You can put wood lining, or itself the building may be of wood, so made of wood logs. So, wood which is available or wood in its different forms can be used as a lining inside the building, which is for the purpose of thermal insulation. If you visit a hotel in a hilly area, when you enter inside, you may find that the room is having a wood lining. It is not only having the decorative value, it has a purpose, because they are cutting down their energy costs at the giving you a pleasing inside aesthetic beauty. So, you are enjoying the environment, but the hotel person is actually getting the return in cutting down his energy bills. So, the functional part lies there. We see very nice applications in our rural India, in the plains where lot of paddy or wheat is being grown. You will see use of straw, thatched roof. We always see roofs having tiles, clay tiles. Then even on top of it you can have straw placed. So, during summer you get a very comfortable interior. So, these sloped roofs are treated with straw on top of maybe bamboo framework or maybe on top of clay to have a thermal comfort. So, what you see like tin roof or asbestos roof are really not the answer, because they trap in lot of thermal energy, but the cushion with straws are filled with air pockets. So, those are actually helping in the insulation. So, you have to keep your eyes open and find out what is the purpose of the material and why people have adopted it traditionally. Now, let us also discuss on green roof and green wall. Is it really giving you an insulation? So, when it is a green roof, yes, it reduces the heat flux through the roof, but it has multiple layers of different things, so that water does not enter or there is no leakage. There should be drainage, there should be soil, there should be a learning on the roots, how the roots of the plants will grow. So, you have to have a good thickness allowed for having green roof. So, automatically it reduces the heat flux through the roof, but at the same time there are multiple things happening in between the layers. So, we have to be very careful to recommend a green roof just for the purpose of insulation. Yes, it replaces the amount of green you are losing at the ground level, and you are replacing that on the top maybe partially, but it does not mean it is giving you a thermal insulation, and that is why you need to do green roof. Same with shading of outer facade, that is vertical garden kind of. You can see this is a picture of from an exhibition. The wall has been created. It was in Milan in 2017, I think. So, this is the exhibition pavilion whose wall has been made green. Now, yes, from outside any shading, not allowing the entry of sunlight, will obviously be an effective barrier to the thermal gain. So, instead of putting an internal insulation, you are giving a different kind of look to the building and at the same time preventing the sun rays or the surface to get heated and heat being trapped inside. But in both the cases, one has to be very careful on the drainage part, otherwise it will lead to damp. Already we have discussed that at length. So, your roof will lead to become a leaky one, it will finally disturb the structural roof and finally it may ruin. Same with case of wall, the wall surfaces you have to be very careful on the roots etc. and also on the water logging. So, now let us come to the material bitumen, or maybe bitumen is one material which was extensively used in damp proofing when we are talking about building, but bituminous materials are widely, maybe 80% of bituminous materials are used for roads, which is not under our purview, but we always have seen on road a black jet color being heated and being applied on road or being mixed with aggregates and being spread on top of the road to have a layer on top of the road. What is this bituminous material? There are two types, one is bitumen and the other is tar. Tar is again obtained from coal or wood. So, you can have coal tar or you can have wood tar. And bitumen, if you say, bitumen may be naturally occurring or may be obtained from petroleum industry. So, it is a kind of very thick, maybe crude oil. So, naturally occurring, it may be bitumen in forms of lakes. I think there is a picture, you can see this is a bitumen lake, and you have to use this bitumen for your purpose. So, you need to know what is it, how it is to be extracted or taken. So, it is a non-crystalline thermoplast and obviously we use it mostly when it is derived from petroleum. It is something solid, somewhat viscous, it is non-rigid, it does not have any shape, fixed shape, and it can absorb shock, it can change shape. It has a softening point, but not a melting point. So, it softens and at a temperature and then you can actually work with it. Majorly as it is organic in nature, it is carbon, hydrocarbon rather, with very traces of some sulfur, some other minerals. It is soluble in carbon disulfide, that is CS2, and yes, it is a recyclable material. It is a very impervious material, it can be continuously used, it is weatherproof, it can sustain temperatures, it can sustain shocks. So, all the qualities we had discussed for a damp proof membrane are with bitumen, and hence it is extensively used. It is unaffected by air, water and sunlight separately, but with long term exposure to all these three, it slowly oxidizes and gradually it loses its strength, it becomes brittle. Chemically it is inert and impermeable, as I have already mentioned. There are two parts, one is petroleum, other is asphaltene. The petroleum is the liquid or the plastic part which is saturated hydrocarbon, and the asphaltene is the hard and brittle part which is having high molecular weight phenols. So, these two when mixed in different proportions, you may get different consistencies. So, when you are getting or extracting bitumen, if you know the petroleum and the asphaltene, you will understand whether how much viscous it will be or how much solid it will be. So, coming to the available forms, as we had discussed during damp proofing, majorly we had discussed it as a membrane damp proofing. So, what is that membrane of? When it was surface treatment, we were talking of a layer of bitumen, say around 3 millimeter, and then what is that of? So, when we are talking of the surface treatment, it is an emulsion form in the form of paint. It is globules of bitumen, say around 2 microns in diameter, suspended in an aqueous medium, and this aqueous medium is the stabilizing agent, is the dispersing agent, which is again having some stabilizing agent added to it, and this aqueous medium actually helps spread these globules and it eventually evaporates. So, we have rapid setting, medium setting, slow setting. Usually it is petroleum or spirit or naphtha. When these three things help, these three of them are the aqueous medium onto which these globules are dispersed, and this gives you the paint like or hot mopping or brushing like material or form of bitumen. Then we have cut back bitumen, which is fluxed with coal tar or petroleum. This takes time for curing, but it is used for sealing applications. You can use cut back bitumen for sealing joints, sealing cracks. Now, this cutter is actually the coal tar or the petroleum, and hence it is called cut back. We had seen applications of sheets, bituminous felts, which were mostly applied on the rooftops. You can go back and see the lecture where we had shown the torch application. So, those are bituminous felts, which is blown form of bitumen. So, you have an unwoven felt or a fabric onto which under high pressure bitumen, liquid bitumen is blown. So, that passes into all the gaps of the fiber, unwoven fiber which is the felt and which is available in different thicknesses, and this under pressure the bitumen moves into it when it is blown. So, these tar felts, the bitumen felts which we see is actually blown form of bitumen. It is not pure bitumen, it has woven fabric, unwoven fabric inside it, which is called felt, and hence it is called bituminous felt. Mineral dust is sprayed on top of it, which is below 600 micron, and you can feel that gives it a rough finish. you can see, visit rooftops at some places, maybe even in your home, and you can experience what it is, apart from seeing pictures. Modified bitumen. When you can put plastic as the core, it is called plastic modified bitumen. When it is crumbled rubber as the core, it is called CRMB or crumbled rubber modified bitumen. So, this crumbled rubber or plastic is the modifier. What is it modifying? It is modifying its capability to withstand higher temperature. It is looking for more age, it is getting more age, it is experiencing lesser crack. These are used mostly on roofs or maybe on road surfaces, where it is continuously exposed to high temperature. So, that is modified bitumen. It may have use in large spans of roofs. Plastic bitumen again is used for filler in cracks on walls. It is pushed through by the process of graniting or by grouting in foundations, etc. So, after laying bitumen, I hope you understand that this black, dark, ugly material, how friendly it is to a building. All substructures are sometimes bitumen painted, that is, it is painted so that it does not get ruined by the underground moisture. Many applications of bitumen is there where bitumen is actually saving the major structures. Now we come to gypsum, which is a mineral which is rich in calcium, which is a calcium sulfate and white in color. On heating, it loses its luster and gains weight because it has water or hydrate. It is hydrated calcium sulfate, and when it is heated, it loses its water and it gains weight. But we have learned gypsum in a different application when we did cement. Here again we have learned gypsum in making gypsum boards, perforated gypsum boards as a sound insulator or a cover to a thermal insulator or an internal protective layer. We had also learned gypsum when we did glass, where it was glass fiber reinforced gypsum. So, gypsum has plenty of applications, and these are actually crystalline in nature and it can be molded when it is wet. It can be taking any shape when under pressure, it can take even hand pressure. So, with hand you can actually make any shape and it gets dried very quickly and it gives a finished item, maybe sculptures. We say plaster of Paris sculpture. We do casting when someone's leg is broken. We do a plastering, that is again gypsum. So, when water is added to the powder, it forms an interlocking crystal which is fire resistant. So, when we were putting the gypsum board in front of a thermal insulator embedded inside, sometimes the thermal insulator may itself be a fire, maybe inflammable. So, to protect that, the gypsum board is actually acting as a barrier. Now, this water of crystallization, what we were talking of, loosely connects with gypsum, but when it is heated, it is half hydrated gypsum and it loses 1.5 molecules of water. and these reactions are very reversible. It rapidly dries, gives a smooth finished surface and minimum shrinkage. That is very important, minimum shrinkage. So, it does not lead to cracks. Shrinkage is the cause of crack. Gypsum is a finish material because you are putting on top of a wall which contains the insulator. So, finally, you are looking the gypsum surface. Finally, you are looking at a false ceiling which is again gypsum. So, it should be having a very seamless look, no cracks, no breaks. Plaster of Paris, where 75% dehydrated gypsum is used, is giving you a smooth surface, as I told you. For interior wall surface, you can make different molded forms of within the interior wall surface in ceilings, carvings. It is better than cement plaster at times. You can compare it like it is non-microbial, it is rust preventive, it does not allow water, it is lightweight in comparison to cement plaster. So, if you have a very good interior with good quality brick with nice pointings, you can actually finish with plaster of Paris and instead leave the cement plastering. Coming to the actual applications where gypsum is used as a dry wall. You see this picture, you can see a half dry wall. This is a half dry wall made of gypsum. These are full partition, full length partition walls made of gypsum. It can be used as a glass fiber reinforced gypsum. It can be used as a rapid wall, that is called a rapid wall because it can be rapidly constructed. You may go to module for glass where it was discussed at length. This is promoted by BMTPC and a building has been made in IIT Madras. This is glass fiber reinforced gypsum. So, this is again a rapid wall construction system where the external wall can be of having gypsum as one of the components. It can be used as false ceiling in air conditioned rooms like computer labs, some chemical laboratories, etc. Gypsum board itself has a low R value, but it can actually provide a barrier from flame affecting the inside of a thermal insulator. So, it can actually cover foam insulation, that is we had discussed on polyurethane spray foam, which is flammable. So, if you coat it or cover it with a gypsum board, you can actually get the benefit of using gypsum. We were discussing earthen pots on the very initial slide. The R value of earthen material is also like 0.5 as compared to glass wool etc., which is around 3 to 4. But even then that entrapped air gives it a better or improved high value, improved R value. So, as a composite with air entrapped within it, it acts as a better insulator. So, here also you see in this GFRG, these are air pockets inside the material So, these are all hollow and this can act as a, these are all hollow and this can act as a insulator, though it has very not so high R value, maybe a low R value of around 0.5. We see other applications as sound insulator. We see that smooth reflective ceiling inside a boardroom, what you see here is because of gypsum. You see here the perforated gypsum board covering, the thermal insulator. You can see a very closer picture here. You can see the insulation inside through these perforated boards. This picture has been taken from one of the lecture halls here at IIT Kharagpur. So, there is an insulation embedded inside and on top of it, it is the perforated board, which this is a closer view and that is the overall view. So, this here it is used as a, it has acoustical application. Here also it is reflecting sound and is having acoustical application, other than giving the room or the ceiling a neat finish. So, through these examples, I hope I could touch upon the major uses of gypsum, the major uses of damp proofing, the bitumen, etc., insulation, how it has been done, how it is being done and traditionally what were done. So, you should be aware of these materials and we need to know these and their particular or specific applications, and we need to recommend as an architect in your later professional life. So, thank you.